Hello, and welcome to today's episode of Rawkode Live. My name is David Mackay, also known as Rawkode across the internet. Today, I am very happy to be joined by Ihor, a cloud native ambassador and advocate for the Cloud Native Computing Foundation. Hello, Ihor, how are you?
Hi, David. Doing great. Thank you for inviting me. Really excited to be here.
Yeah, it's going to be really good. I think this is one of the most important episodes that I've done to date. Like normally it's hands-on and playing with a technology, but today we're actually going to tackle some of the more meta questions around what is cloud native and how to adopt cloud native and all of this stuff that people either read about online or consume from talks at conferences. But sometimes it's just nice to sit down and get really specific and help break down a few of the barriers to cloud native adoption, which is why I'm so excited for today's episode. I think it's going to be great.
Of course, we'll try it.
With that in mind, what I would suggest to anyone watching live is that we really do want participation with today's episode. So if you have a question that you would like us to answer, and it can be anything cloud native related, we'll do our best to tackle that. The way to do that is use the comment system on YouTube, or you can tweet either of us, and we'll do our best to bring that into today's episode. We do have a collection of questions that either I, Ihor, or people from our Discord community or Twitter have submitted previously. So we're going to start with a few of those. And anything that you want us to drill down onto, please do not be shy. Get those questions into us. So let's start with a little bit of conversation around you. You are a developer advocate for the Cloud Native Computing Foundation. This must make you the foremost authoritative answer on what is cloud native. Would you agree with that?
Yeah. So the question about what is cloud native is probably one of the most simplest and one of the most complicated questions in the technology world. So it may take a few hours for us to discuss everything in details.
All right. Well, we can maybe we'll go with the abridged version, I think. So, I mean, is it safe to say that your job, your role is to help people and promote cloud native? Is that what a developer advocate at the CNCF is responsible for?
Yeah, so my job is an intersection between the classic technical developer relations like developer advocacy, like trying some new tools, working with the developer communities, working with the technical communities, writing some blog posts, trying demos and so on, and promoting the technologies across the technology world. And at the same time, I'm also deeply involved into the various program management aspects and community management aspects of the cloud native community. So we have some unique specifics of our organization. So Cloud Native Computing Foundation is not regular, let's say, vendor or product company. We are the independent nonprofit foundation, which is hosting various technologies under our umbrella, and we're mostly interested in spreading the word around these technologies, but not adding some some commercial focus to these technologies and so on. So my average job, it can be a bit more different than the average day job, the average responsibilities of the typical developer you get from the product company. At the same time, we are all doing the same job. We're promoting these technologies. We are connecting the bridges between the technical communities, between the developers communities, and those people who are trying to consume these technologies or making decisions about implementation of these technologies in their ecosystems.
Awesome. Really cool. I mean, you get to, on one hand, A, play with all of these technologies on a regular basis, but B, you're also very closely connected to the community through those initiatives that you just mentioned. So you also get really good first and second hand discourse with people that are either adopting cloud native or already have adopted cloud native. And we're going to get all of that knowledge out of your brain today and transmit that to everybody that's watching on YouTube. So, we have our first hello, John. Thank you for tuning in. So let's just try and see if we can not spend a few hours, but maybe a few minutes just covering what is cloud native. If we had to sum it up in a 30-second blurb, what do you think the most important parts, components, concepts, etc. are of cloud native?
The most important components of cloud native is an ability to bundle the different things into some shippable and easily distributable units. They're typically called as containers, but it's like being containerized is not absolutely necessary to be cloud native. At the same time, the way to implement your technologies, like we are exposing the APIs and using some service mesh technologies, or adapting your tools to be easily deployed on the different public or private clouds on premises is the other essential parts of the cloud native world. CNCF has its own specific definition of what cloud native is. You can find it under the CNCF repo on GitHub, under the CNCF TOC repo on GitHub. So you can find this brief definition there. On the various languages, not only in English, so I can share the link later, and probably David can share the link later with all the subscribers here. But in general, again, the cloud native technology is the technology that can be easily used and easily packaged and easily distributed across various platforms, be platform agnostic, and can be easily distributed across.
Oh. I don't know if that's my connection. If anyone can still hear me, if you can let me know, that would be grand. Or if we have potentially just lost Ihor. I'll wait for a thumbs up from somebody. Otherwise, I'm going to the pub. Oh, Ihor, are you back?
I'm back. Yeah, sorry, I had some connectivity issues. For some reason, they're happening exactly at that time when we're doing something live.
It's all right. You seem to be perfectly great now, so we'll just put that down as a wee blurb, and we'll see what happens.
All right.
Okay, so I think you kind of covered what cloud native was there. The thing that struck me right away was you said that you don't need containers to be cloud native.
You don't necessarily need containers. However, in like 99% different cases, containers are essential. So containers is the organic part of the cloud native world. And if we'll come back again to the history of the Cloud Native Computing Foundation as an organization, our first and second project was Kubernetes, a project that has been developed by Google originally to host containers and to manage containers on the various scale, in the various cases across the globe. So the first project even for the foundation was the container-focused project, and most of our projects even these days, they're also container-centric.
Yeah, I mean, I think just from my own experience of speaking to people, you know, at events last year, of course, not this year, or even online this year, is that, I think there's this kind of, I don't know if it's, maybe it's a rule or maybe it's some sort of misconception, but the idea that cloud native and Kubernetes are actually entangled to a certain point, and that I feel just on the conversations I had that people don't think you can be cloud native without Kubernetes. And is that something you would say is untrue then?
It's not truly true, because you can run containers without Kubernetes. You can be even a cloud native without containers. However, again, Kubernetes is the essential part of most of the container-focused infrastructures these days. Most of the container environments these days are powered by Kubernetes for obvious reasons. Kubernetes has enough benefits, so why should you use it in the various cases? However, it's obvious that you shouldn't use the same technology for all the cases. There are various scenarios where Kubernetes is not really necessary. It can be you can just use, for example, Docker as the container runtime and the basic container orchestrator on your local machine, for example, and so on. So containers and Kubernetes are pretty close to each other, but not synonyms.
Yeah, I guess maybe it would make sense if we kind of try and cover what are the main kind of problems that cloud native can help organizations solve. Like, if we understand what it is and we understand that maybe you don't need Kubernetes, then what does cloud native aim to solve? And then maybe we'll lead us on to what Kubernetes helps solve some of those challenges too.
Sure. We can come back to the benefits of using containers themselves, not necessarily the cloud native as an abstraction. So you can use containers everywhere these days. And one of the benefits of using containers and packaging your applications into containers is that you can use, for example, your local laptop to write some application, bundle your code within container, do it like in a few commands and then in a few seconds, and easily ship and run the same application on the public cloud, in a private cloud, or in a remote data center that is located in a few thousand kilometers from you. And this is one of the obvious benefits of using containers. And again, being cloud native means that you can use all the benefits that that these abstract environments can bring to you. Like there are even various cloud providers that are not only offering the public cloud offerings. When we're speaking about cloud, when most people are speaking about cloud, they are mostly using this term to describe some kind of public cloud, for example, some well-known infrastructure that is being run somewhere by some third-party vendor. They don't have any access to the underlying infrastructure. They don't have any control to it. However, there's a concept of the on-premises infrastructure or private cloud. And if you're using the private cloud, you're basically using the same bare metal machines as you can use in your regular physical data center. And private cloud is essentially the same physical data center. However, with an additional set of abstractions, with an ability to control your infrastructure using the API and the declarative way of managing these things, you can convert and you can migrate your existing legacy workloads and the legacy ways of using applications and deploying applications into something different. If we're speaking even about the hybrid cloud approach, so you can even use the same set of instructions, the same set of API rules in some cases, where you can run the same applications on the private cloud within your own data center in a public cloud that has been deployed somewhere. And here comes Kubernetes. So this is the answer to your next question that you were about to ask, Ned. So why Kubernetes is it's really beneficial for various use cases. The reason is that you can use the same Kubernetes cluster or the same way of controlling various Kubernetes clusters because of the Kubernetes API, which is not changing, even despite the fact that you can use the same Kubernetes cluster in a public cloud, or you can use the different Kubernetes cluster in a private cloud in your own data center. But you'll still use Kubernetes, the same code base of Kubernetes. This means you will have the same stable API. You can simply run even your simple Python commands, for example, that will provision some applications on Kubernetes. So Kubernetes is the next level of abstraction, and it doesn't matter which kind of infrastructure do you have below the Kubernetes level. Wherever you can deploy Kubernetes, you can interact with Kubernetes. You shouldn't interact with the underlying infrastructure directly if you are trying to deploy and manage your applications.
Okay, so you can still be cloud native if you're on a public cloud. You can still be cloud native if you're on private cloud or bare metal or multi-cloud or all these things. These are all cloud native. You can use Kubernetes if you want or containers if you want, but you're going to get a lot of benefits if you do. One of them being that you just said there is Kubernetes gives us an API we can deploy to. Containers give us the ability to not just distribute the images, but have some level of idempotency between what we run across machines. Like, there's already a lot of layered benefits here that the more, what's that phrase? The sum of the whole is greater than the sum of the parts. Like when you add each of these bits, you're just building out a more robust and resilient system. Would you say that is the goal for people that are adopting cloud native, is just to architect their systems in a way that is more robust or more scalable? Is that a core tenet of cloud native?
It's one of the benefits, and this is one of the primary reasons why people at companies of the different size and different scale are implementing these tools and using these tools, specifically Kubernetes. You can use Kubernetes on a single node machine on your local laptop, and you can also use Kubernetes in your distributed various data centers across the globe with the scale of the single cluster of up to 5,000 nodes per cluster. So, and you'll still use the same Kubernetes. So this is the benefit. You'll still use the same tool. You don't need to learn yet another tool to use it and to run some pieces of code there.
Okay, then. So let's continue down this path then. So something that is very prominent with cloud native architectures and people that I speak to that are adopting this methodology of building software is microservices. And I believe that the CNCF original definition did say that microservices were required to be cloud native. Is that still the case, or do you feel that that's changed a little bit these days?
Yes and no. So microservices should be there where they're required. At the same time, the cases where microservices are required are almost everywhere. The most typical use case for still using some monolithic application can be migrating this monolithic application from some legacy workloads and inability to easily convert it into the microservice. So I know that there are even some customers, some companies that are using Kubernetes even to bundle some things, some applications that have been developed even like 20 or 30 years ago in the mainframe era, for example. They're using Kubernetes, they're using some kind of emulators to bundle that code within some abstraction that can be easily consumed by Kubernetes and can be provisioned and run on the Kubernetes cluster. However, if you're developing and building the new application specifically from scratch these days, it's more or less obvious for most cases that you may and should use microservices because it's the most efficient way of managing various resources. Especially if we're speaking about the public cloud infrastructure, for example. If you're not using some bare metal machines which have kind of limited capacity comparing with the public cloud, where you can basically run anything and anywhere. So microservices is the preferred way of running applications. It will be way more resource efficient for you. It will be way more efficient in the terms of the lifecycle management of your applications and so on. So there are enough benefits. Why should you use microservices these days? However, as I mentioned before, you shouldn't use microservices everywhere, like in 100% of cases. If you feel that you don't need microservices, you probably don't need them.
Okay, let's prod into that a little bit then. So I think that's definitely a question that probably most people have is, I'm starting a new side project. Do I start with microservices, and is that going to have an effect on the velocity that they can ship the first version? Because there are a whole lot of challenges that come with microservices. I mean, maybe we could talk about how Kubernetes solves a few of those.
Yep.
Or, for someone starting up a new side business or a new startup, building a monolith might just be a lot quicker for them. But then the technical debt they accrue as they build that out is also going to have all these challenges too. Like, what is the answer? Is there a single answer?
There is no single answer. There is no single answer for all use cases, for all companies, for all applications, for even all the types of applications. There are various applications that can be easily bundled and packaged into the microservices. Even some legacy applications that have been built like 10 years ago, they can be easily split into the microservices form even today when we're speaking about some stateless applications, for example, some static websites and so on, so something like that. When we are speaking about something more complex, especially when we're speaking about some cases where you have to store your data, like databases or some complex storage solutions, especially the networking storage solutions. So probably it's not the best case just to go ahead and convert your existing applications into the form of microservices. You can also combine it. So there's no direct answer. Should you use microservices everywhere in all the cases? However, I would strongly encourage people to consider using microservices, and if there is a possibility to use them, and if there is a possibility to be cloud native from scratch, from the first steps, this should be it can be the preferred way of using things these days.
Okay, so right away, like let's try and play this on both sides of the fence then. Let's assume you and I were speaking to a new company and we're saying like microservices are the best way for you to start this new application. Now, immediately to me, the first thing I'd want to say is a tangible benefit is the microservices should be small enough that they're really easy to iterate on, build, test, and deploy. What are the other advantages then to microservices?
There are enough advantages around microservices, so you can easily, you can easily develop them. So if you can easily develop the different components of the microservices, architecture on the single atomic pieces. The whole complex structure of the microservices application compared to the monolithic application can be even more complex because of these various connections between the microservices. Between the microservices pieces and the different ways, and probably even different languages which are used to write different parts of this microservices application. Again, with monolithic application, it's way easier for you, as you mentioned before, David. So for some startup, it can be way easier just to write some monolithic application just from the scratch, just try some basic things there and ship it, even in production. But what about scaling it? What about migrating and distributing this application across various cloud providers, for example? So let's say you have a monolithic application that is being run on the public cloud provider A, but you may have some issues with that cloud provider. You can have some, for example, your country can restrict your access to that cloud provider like on the next day, and you have no access to that, and you're trying to migrate the tool, you're trying to migrate that application to the different place, but the cloud provider B has no direct way. How can you just click and run the same application and migrate it from cloud provider A to the cloud provider B, or the different cases? Like even if you have some, for example, billing issues with your current cloud provider, and you're trying to resolve your issues with the outstanding payments with your previous cloud provider, but you already have enough credits on the cloud provider B. So in the microservices world, you can easily move these pieces from cloud provider A to the cloud provider B and run them almost seamlessly. With the monolithic tools, it can be complicated. It's not necessarily complicated in all cases, but monolithic application makes you less flexible. You are less flexible also in terms of development. So if you're trying to upgrade some minor but essential piece of your monolithic application, you'll have to rebuild the whole application. It will take some time. It will take some development resources. It may have even some compatibility issues in the future. But if you're upgrading the small piece of the monolithic microservices application, if you're upgrading a small piece of the microservices applications, you're just upgrading that single piece, and that's it. All the remaining parts of your microservices structure will remain the same and unchanged, and you don't have to rebuild them again from scratch and test the compatibility with the new platform and so on. So again, various cases. If you're just running something like the basic front end application on the single machine that is located somewhere, and this is the primary business case for your organization, you may consider just using that static website, even not containerizing that, just running something like an Nginx, and that's it. Yep. At the same time, if you run different pieces of the application, like the front end app, back-end app, some database, some extra additional pieces of code that should be added as the extensions and so on. So it was considered converting this architecture into the microservices one.
Okay, there was a lot there. There's some really great points I think that people need to consider when they're tasked with this question at their organization. I mean, I think what I'm taking away from what you said there is like cloud native should probably be the default, and you should identify which use cases, which applications shouldn't be, rather than the monolith is the default and then trying to work out when to be cloud native. So people that are listening to this should just say, okay, this is a cloud native application until I have a reason not to do it. Yeah. The other kind of really prominent thing that you came back to a few times there was just the fact that the microservices allows you to contain logic into small sections, small parts that we can move out, we can replace, we can iterate on, and the amount of knowledge you need to be able to do that is much more minimal than having to understand like a whole car, for instance. You might just understand the steering wheel, the gearbox, the clutch, etc. And I think that works really well. So let me turn the question around a little bit then. Is microservices and cloud-native architectures allow us to build smaller components that we can understand. Do we remove the simplicity from our do we remove complexity from our applications, or is it just pushed away somewhere?
It's a fun fact that when we're comparing again microservices and monolithic applications, we're adding extra complexity to the microservices applications, because again you have to connect together various pieces of the different pieces of code. For example, how can you bundle easily? How can you connect easily some piece of code that is written in Python, for example, and Go? It's almost impossible in the different cases, like with the monolithic applications. With microservices, you'll have to add some extra level of abstractions just to connect them. In this case, you'll need to have some universal set of APIs within your application, where you can connect these different pieces of your applications that are located on the different sides of this tree. Let's call it this way.
Yeah, the minute we apply this architecture to our applications, we have a distributed application, and that brings a whole host of complexity to it. So while our services are getting simpler, I guess that's all now in the infrastructure there, which is where Kubernetes comes in and saves the day. Would you say Kubernetes solves a lot of the complexities around distributed applications, and how does it do that?
Again, Kubernetes is an extremely complex tool, so it will add enough complexity to your general architecture, but it will remove enough endpoints for you to manage and to use your whole level of your whole set of abstractions there. So Kubernetes is an extremely complex tool, but it will simplify your life in some different cases. Again, a good sample of where and how Kubernetes can be essential for you, I just mentioned like 5 minutes ago. So you can run the same set of applications and control them from the single control plane, from the single control point, even if your applications should be provisioned in a private cloud data center that is located in the United States, and on a public cloud that is based somewhere in Japan, for example. But you can still control the same applications from the same place, from your single control plane, and you as an operator, you'll have to interact only with that single control plane. Everything else will be handled by Kubernetes.
Okay, excellent. Let's tackle a viewer question then, which I think kind of segues nicely right now. So John McCabe is asking, what are some of the common or avoidable missteps or pitfalls when organizations adopt cloud native?
The most common misstep is that sometimes people are considering cloud native as when people are considering that cloud native can solve all their questions, but it doesn't. And the reason here is that cloud native is not a silver bullet. Kubernetes and containers are not the silver bullets. You still have to develop your applications and your configuration and design your architecture in the most efficient way. It's a big mistake to think that even if you develop your architecture and your application in some way, Kubernetes will solve it for you. It's not the case. Even it will be more difficult to adapt and redesign your application and your architecture if if you've developed it in some non-efficient way and to enhance it to be more efficient later. So the basic probably the basic point here, you still have to write some good code and some efficient code to be run somewhere, and it doesn't matter will it be run in containers, be it provisioned by Kubernetes, or just be run somewhere on the pure bare metal as is.
Yeah, definitely. I think that, there's a lot of maturity with regards to writing software that has to be kind of understood, and you have to have solved a lot. You've got to understand some of the problems that Cloud Native solves before you can start applying it as a solution for everything, I think is what's really important. And that's kind of what I got from what you were saying there. It's like, if you don't understand the past problems, then you're just applying a solution that you don't really know what it's solving yet, and that's going to lead you down probably a whole bunch of errors that otherwise you might be able to fix. But I think I made it up right now. I get it. Okay.
Yeah.
So something I've seen a lot, I go to a lot of conferences, as I'm sure you do as well, and people are always asking for what is the first step, and I'm going to say what I normally say, and then say that it's also the worst advice that I always give, and I still give this advice, but I think there's a reason for that. So when people say what is the first step, I normally tell them, just containerize your application and deploy it as it is. Like, just getting, and when I say that, what I'm asking them to do is to build a CI pipeline where they build an image and run it places, which pushes them down the 12-factor path. But then it's also the worst advice to give, because people take that container image and throw it in Kubernetes, and it's the only service, the only pod, and they're just scaling it on the architecture using the Kubernetes API. And I think that's also has a huge detrimental effect on them, because they don't understand the problems that Kubernetes is solving with networking and service discovery and health checks and all this stuff, because they're not necessarily using those components. So I'm curious. I give out bad advice, it sounds, but I'm hopefully trying to help people. What do you think is a good first step for people that want to adopt Cloud Native, coming from maybe a monolithic background?
My advice about the first step would be learn your own code. Know what you're writing, know what you're building, know what you're deploying. If you don't know what you're using, if you don't know what you're trying to adopt for the cloud native infrastructure, there is a high chance that you'll have some issues with the immediate adoption, or you may have some issues later during the adoption cycle. Learn what you're doing, and the second first step is learn that technologies that you're planning to use. Learn Kubernetes. Play with Kubernetes, deploying it on your local machine, on your local laptop, for example. Try to run some basic applications. Understand what kind of potential issues and potential complexity that Kubernetes add to your application and that Kubernetes can add to your environment. The good case, you may have the tiny machine somewhere in a public cloud, David, that whereas cloud providers that are offering like something like the micro VM or tiny VM or something like that, and their public cloud offerings typically is a part of the free tier, where you may receive something like 500 megabytes of RAM, something like one virtual CPU, which is shared across the whole rack where this virtual machine is deployed. So sometimes people are trying to use this tiny VM, tiny machine to run Kubernetes and run some applications within it. But the typical Kubernetes cluster these days might require around one gigabyte of RAM just to run itself. It itself. So you can't run even Kubernetes itself without any workloads on that machine. But you can easily run your small single Golang based application there, for example. So again, learn your code and learn your tools that you're trying to use. As much as difficult to run Kubernetes cluster on a 500 megabytes RAM machine, absolutely the same way it's terribly difficult to run some simple application in a highly distributed, highly scaled environment on a few thousand nodes without any kind of orchestration, without any kind of containerized solutions like Kubernetes.
Okay, awesome. So let's go back to something that you mentioned earlier. When you were talking about microservices, you talked about databases. Now, we did have a viewer submit a question before we started, and their question was, do I really need a database per service? This sounds like an awful lot of work. So do you have any thoughts or opinions or even advice to people that are not sure how to structure their stateful services and databases and backend stores, etc.?
Yeah, again, it depends. It depends on the use cases, of your application and the use cases for your databases. The most typical way, especially in the early days of Kubernetes, that I've been following, and I've noticed that multiple companies and even multiple enterprises have been using, is that you use containerized services and the cloud native technologies and the cloud native architecture for the stateless services, but for the stateful workloads, you use some dedicated database cluster that is just plugged into your Kubernetes cluster, for example. So your database should not be necessarily containerized, and it should not necessarily be being run within the Kubernetes cluster, for example. But you can still use all the benefits of using the stateful services with Kubernetes. But again, there are so many various cases where you should use even databases with Kubernetes, and there are enough cases where you shouldn't do it.
Yeah, I think this is a hot topic in Kubernetes land about should I run stateful workloads in Kubernetes.
Yeah.
I am firmly on the yes. I think we should be running our databases in Kubernetes. I think if we look at the benefits, of health checks, reconciliation, as long as you can solve the storage problem, and we can talk about CSI drivers. Not something I'm particularly knowledgeable about, so maybe I'll avoid that as much as I can. But I think there's a lot of benefits to having stateful workloads in Kubernetes and being able to plan for failures. Things are going to go wrong, but then we learn how to fix them. Whereas, I don't know, that the concept that I've got a Kubernetes cluster. Sorry, I'm ranting now. I've got a Kubernetes cluster and I'm running my stateful workloads on VM somewhere else that could still have the same problems they would inside a container environment. I mean, in fact, here's a question. Sorry, I'm
of course
going off on one now. I always tell people there's no difference from running a database in Kubernetes using a host path mount and fixing it to a node than there is just running that process on a node. I mean, is that something you would agree with, or something that you think I should stop saying?
I can't respond immediately. We have to follow up on that. So as you, I'm not sure about the correctness of this statement. So let's keep this and discuss later.
No problem. I'll maybe just rant about that on Twitter at some point and have the internet tell me why I'm wrong. But
a good point for the Twitter poll, right?
Okay, let's jump back to a few viewer questions then. So we had a few questions that were essentially along the lines of, do I need X in order to be cloud native? One of them was CI/CD. One of them was good monitoring. Are there any prerequisites that people need to be good with before they could be cloud native? Or, I mean, is this just good code hygiene in general? Like, people probably should have CI and CD regardless of being cloud native. And what are your thoughts on that?
I agree with your point on code hygiene. I agree with your point that CI/CD tools are mostly essential in the most complex environments these days. Even if you're not using Kubernetes, for example, or if you're not using the containerized clusters, if you are running and if you're releasing your applications if you're developing your applications frequently, if you're releasing the new pieces of code regularly, you have to use the CI and CD tools to deliver them properly. So it's an unrelated, it's a related but unrelated topic to the cloud native world and to the cloud native architecture patterns. It's a good practice to use CI/CD tools with the complex environments, It's not really necessary in some cases. Again, if you have just released your single version of your application and you don't expect to release any version of your application in the foreseeable future. So again, CI/CD tools can add extra complexity to your code base and to your infrastructure. But if you're releasing your applications frequently, if you are releasing some updates frequently, if you are deploying some patches there, so you should use these tools. Again, not necessarily with Kubernetes exactly, and not only with the Kubernetes clusters, but it's just the good practice for everyone who is doing these things.
All right. So yes, you should have CI/CD. Yes, you should have good monitoring. It's not necessarily a prerequisite to build out a cloud native architecture.
Exactly. Yes, exactly. So it's not the definition of cloud native to use CI/CD.
Yeah.
And it's not the definition of the cloud native application, but in theory, right? But in the practical world, in most of the use cases, you should use, and you should have some good monitoring tool. You should have some CI/CD tools that will be embedded into your architecture. It should be the organic parts of your architecture.
I think we've kind of also answered the final viewer question there as well with our kind of answer there. The final question was, does cloud native complement or compete with methodologies like Agile and DevOps? And I think the same answer applies here, is that you just should have all these good practices in place, regardless of being cloud native or not. And then cloud native is just going to hopefully enrich those processes that you've already built through good engineering, I guess.
Yep. The term DevOps or Agile, they've been emerged way before cloud native definition has emerged. But today they're typically used in the same sentence. Again, they're not synonyms, they're not meaning the same, but they are complementary. And with the cloud native technologies, you can boost your DevOps partners in a way more efficient way that you could do before, like 10 years ago, for example, when cloud native was not a thing.
Excellent. Cool. I think we've answered a lot of really good questions there.
Awesome.
So is there...
Good news.
Yeah. No, it's such a... I think there's a lot of misconception. I think there's a lot of ambiguity. I think you see so much, on Twitter and through articles about cloud native, about Kubernetes, about all these tools. Of course, KubeCon and the cloud native cons are just such massive events that there's a lot of buzz and a lot of, I guess, for the people that haven't gone down this path yet, maybe a lot of fear as well. It's quite intimidating, and hopefully just taking a few of these questions and giving people a little bit of confidence and insight into what they need to do this is really going to help. So thank you very much for joining me today.
Thank you very much, indeed.
If you have any final thoughts, you may drop them now. Otherwise, again, thank you very much. It's been an absolute pleasure.
Of course. Thank you for inviting, and glad to be here.
All right. Well, thank you. You have a great day, and I will speak to you soon. Adios.
Perfect.